We've all seen the dazzling potential of retrieval augmented generation, RG. You ask your AI a complex internal question, and it pulls this perfect, nuanced answer from, your huge stack of internal documents.
Hmm. That's the magic, absolutely. But you've probably also seen the horror story, right? An AI confidently giving out, say, a customer service answer or a financial quote, but it's based on a pricing sheet from like 2 quarters ago.
Yeah.
That's not just wrong. That's actually dangerous. That's what we mean by confidently unreliable AI.
And that really gets to the core problem, doesn't it? An AI agent is really only as smart, only as reliable as the data you feed it. But data isn't static, it's alive. It changes constantly.
Every day.
So today, we're diving deep into how you build these essential automated data pipelines. They act like the guardians of your AI's knowledge base, making sure it's always in sync, always accurate, and, well, trustworthy.
Welcome to the deep dive, everyone.
Yeah, we've got a fantastic set of resources today, all focused on taking Arche systems from just a cool demo to something actually reliable for production. Our mission today is pretty straightforward. We are tackling that chronic problem of expired data.
We're going to lay out a blueprint, essentially no code, for building a fully automated RJ data lifecycle manager. We'll talk about tools like n8n for the automation part, Google Drive maybe as the source for files, and Supabase as the vector database.
Yep. We'll start with the basic pipeline ideas, the foundations. Then we dive into the three really critical automated workflows: create, update, and delete. We call it the C.U.D system. They have to work together.
Okay.
And finally, we'll touch on how you scale this whole thing up using smart routing.
Okay, let's unpack that shift first. A lot of teams, when they start with RJ, they just upload a folder of PDFs once, right, and think they're done. Why do we actually need a complex, continuously running pipeline beyond just that first upload? Well, because if you just rely on that one static upload, your AI is basically frozen in time from that moment on.
Right.
The second the first document changes, the whole system starts to decay. And an AI with an old database, it isn't just a little bit wrong, it's confidently wrong about things that really matter.
Mm-hmm.
That unreliable confidence, I mean, that's just a disaster waiting to happen for any business trying to use AI for real work. So you need continuous kind of invisible synchronization.
So we're essentially shifting the focus. It's less about endlessly tweaking the language model itself and more about the plumbing, the infrastructure that supports it.
Exactly. Think of it like having a brilliant, Michelin star chef that's your LLM, but you force them to cook with expired ingredients in a kitchen that's a total mess.
Yeah.
The results, no matter how good the chef is, they're going to be disappointing, maybe even harmful. The data pipeline, that's the hidden hero. It's the professional kitchen management system, keeping everything fresh and organized.
The source material we looked at outlines three key stages that every solid RAG data pipeline needs to have. It's kind of like that professional kitchen workflow you mentioned.
Yeah, stage one is the raw material. That's your input, right? The groceries showing up at the loading dock. These are your PDFs, your Word docs, maybe raw text from a web page.
Okay.
Stage two is the processing line. Think of it as the prep station. This is where the really crucial transformation happens. You clean the data, you add important metadata, you break the document down into smaller pieces or chunk it, and then you generate the embeddings.
Let's quickly define that jargon. A vector database stores embeddings. These are basically the digital fingerprints the AI uses to understand and find the right information.
Exactly. Those fingerprints, they're the result of that processing stage. And stage three is the final product, the organized searchable storage. For a RAG, that's almost always going to be your vector database.
And every pipeline that actually works, no matter the tool you're using, it has to be built around four essential components. What are those four?
That's right. First, you've got triggers. That's like the doorbell that kicks off the whole process. A notification that a file change or something new arrived. Second, the inputs. That's just your source files themselves. Third is processing all those steps to transform the data into vectors. And finally, storage, which is the vector database where it all ends up, like Supabase.
So why is getting these four components right the key to reliable AI?
It lets you manage the full data lifecycle, ensuring your AI is always trustworthy. Right? So to get that truly automated, trustworthy AI, you can't just stop at creating data. You absolutely need three interconnected pipelines working together. That's the full C.U.D system. Create, update, delete.
And the source material shows this using n8n for the automation and Google Drive as the file source. But like you said, the ideas apply no matter the specific tools, right? It lets us map out the whole data lifecycle with these low-code or no-code tools.
Totally. So workflow 1,
Yeah.
initial upload, create. This one's the easiest usually. It gets triggered when a new file shows up in your designated folder. It downloads the file, adds that critical metadata, we like calling them digital dog tags, and then just inserts the new vectors into your database. Simple, clean, creation.
Then workflow 2, document update. This kicks off when a file gets modified. The file name is the same, but the content inside has changed. And this is the pipeline that often trips people up, you mentioned, because you can't just overwrite the old data.
You really can't. You have to think of it as a very controlled two-step dance. The workflow must first delete all the old, outdated vectors linked to that file's unique ID.
Before adding the new ones.
Exactly. Then it processes and adds the new vectors from the updated file. If you miss that deletion step, you just end up with junk in your database, old and new answers mixed together, conflicting information. It's bad.
And workflow 3, the document deletion part. This one uses a pretty clever workaround, doesn't it? Since things like Google Drive don't always reliably tell you when a file is truly deleted, what's the trick?
Yeah, the trick is you don't wait for a deleted signal that might never come. Instead, you treat deletion as an action. You manually move the file you want to delete into a specific separate folder, like a recycling bin folder you create.
Ah, so the move is the trigger.
Exactly. That movement into the special folder acts as the reliable trigger for the third workflow. And that workflow's only job is to then run the process to delete the corresponding vectors from the database.
That's actually a really elegant way to handle it, using a dedicated folder as the deletion signal. So looking at those 3, create, update, delete, which one would you say is the most technically tricky or nuanced to get right?
The update pipeline is the trickiest because it requires precise identification and deletion before re-uploading the new data.
Okay, so let's dig into the guts of that update pipeline. Workflow 2 again. Why is metadata, data about your data, why is it so absolutely critical for making both the update and the delete pipelines actually work?
Oh, metadata is your absolute superpower here.
Yeah.
Seriously. For managing this REG lifecycle, you usually need at least 2 critical pieces in there. The unique file name or some kind of file ID, and maybe the last modified date.
Right.
The file name is that specific unique identifier, the digital dog tag, like we said, that lets you find every single chunk, every vector that came from that one original source file.
That makes total sense, especially when you think that, say, one 10-page document might get broken down into 50 or 60 separate vector chunks in the database.
Exactly right.
Yeah.
You need that single shared ID, that common thread, to basically tell the database, hey, run a query, delete all the vectors where the metadata matches this specific file ID.
Without that.
Without that ID, you're lost.
Yeah.
You're trying to delete like individual atoms without knowing which molecule they belong to. It's impossible.
I still wrestle with managing metadata fields properly in my own projects, and I've definitely seen workflows fail silently just because, say, the case sensitivity of the file name in the metadata column didn't perfectly match the new file name.
Oh, yeah.
If that mapping is off by even one character, the whole deletion step just fails quietly, and your AI keeps the old wrong answers right alongside the new ones. It's a terrifyingly common trap when you're automating things.
It absolutely is. And speaking of traps, there's this one critical, really simple setting related to the download step after deletion that can save you so much headache and, frankly, money.
Okay.
So after the deletion step runs, right, it often outputs a whole stream of items, maybe one little signal for every single vector just deleted.
Right. If it deleted 50 chunks, you get 50 signals coming out.
Exactly. Now, if you forget to enable this simple setting in many tools, it's called something like execute only once on the next step, the file download step.
Uh-oh.
Oh, it's right. That download node will then try to run multiple times, completely redundantly.
So you could end up trying to download and then process the same, say, 10 megabyte PDF file 50 times, just because 50 deletion signals triggered the next step 50 times, wasting all that processing power and API calls.
Precisely. It's crazy inefficient. So that simple toggle execute only once, it's not just a nice to have. It's really important for efficiency. It makes sure the file only gets downloaded and processed one time, managing that flow from the upstream deletion step.
Beyond just checking the execution logs for, success codes, what's the most reliable, simple way to actually confirm that the update pipeline really worked as intended?
Testing the AI agent itself. Ask it a question that specifically relies on the new information, confirming it returns the updated policy, not the old deleted one.
Okay.
Okay, so once you've got that core C.U.D system humming along, you've pretty much nailed reliability. But the next thing is growth, right? What happens when suddenly you need to handle more than just PDFs? Maybe DOCX files, Excel spreadsheets, Markdown files start landing in that knowledge folder.
Yeah, you definitely don't want to build like a dozen completely separate pipelines all watching the same input folder. That sounds like a maintenance nightmare. The source material suggests scaling using a single entry point and something they call a smart router.
Yeah.
Exactly. This smart router approach uses a conditional logic node. Often it's just called a switch node, and whatever automation tool you're using.
Right.
You still have just one single trigger watching that one intake folder. But then the switch node looks at the file. It inspects the file extension. Is it .pdf? Is it .txt? Is it .dx? And it intelligently routes that file down a specific processing branch that's built just for that file type.
That's a really powerful way to structure it, isn't it? Moving from these rigid single-purpose pipelines to like true dynamic routing based on the input. 2-sec silence. Whoa. You can really imagine scaling that kind of architecture up, can't you? Handling all sorts of different formats coming from maybe thousands of sources, dozens of different systems, but all converging into one central, unified, up-to-date knowledge base. That's really powerful data management flexibility. It really is.
Yeah.
And it makes adding support for new things super easy. Let's say next month you need to handle audio files or something. You just add a new branch to that switch, build out the specific processor for audio, and the rest of the system just keeps working untouched. That's what true scalability looks like.
We also need to talk about common problems, though, because let's be honest, troubleshooting is always half the battle when you're building these kinds of automated systems. The source gives 3 specific lifesavers for debugging RAG pipelines.
Yeah, the first one, like we touched on, is that metadata check. If your vectors aren't deleting when they should be, it is almost always an issue with exact case sensitivity or just a tiny mismatch in that file name metadata field.
Right.
The smallest typo, a difference in capitalization, it breaks the database query trying to find the match. So check that first, very carefully.
And the second error sounds like a really nasty one, potentially hard to figure out if you don't know what you're looking for. The embeddings mismatch error.
Ugh, it's the worst. If you see that error, it means the embedding model you used in your automation workflow. Let's say you used OpenAI's text embedding 3 small model there.
Okay.
That model must be the exact same model that your vector database is configured to use when it does the retrieval lookup.
If they don't match.
If they don't match, the AI's digital fingerprints, those vectors, they just don't line up mathematically. It means the retrieval completely fails, even if the data is actually sitting right there in the database. It just can't find it.
It's like trying to use 2 different rulers, maybe inches and centimeters, to measure the same thing. The numbers are accurate in their own system, but they're useless when you try to compare them directly.
That's a perfect analogy, exactly. And the final troubleshooting tip is about prepping the source files. If you're trying to ingest, like, live Google Docs or Google Sheets, formats that can change constantly, you absolutely need an initial file conversion step.
You mean before you even start processing the content?
Yes. You have to turn them into stable, static formats first. Convert them to PDF or maybe plain text before you send them down the pipeline for chunking and embedding.
Makes sense. Okay, one last question on efficiency here. For a business that's growing fast, maybe lots of documents changing all the time, what's the biggest advantage of maybe switching from real-time file triggers to using scheduled scans instead, say checking the folder once an hour?
Scheduled scans significantly reduce the total number of workflow executions by processing changes in one single hourly or batch job, rather than triggering 50 individual workflows for 50 small changes.
So wrapping this up, what does this all really mean for you, the listener?
I think the big takeaway is that these data pipelines, they're the critical, often completely invisible infrastructure. They're the essential dynamic foundation that separates, a cool R demo from an AI agent you can actually rely on in a real production business environment. Absolutely. A trustworthy, accurate AI agent, it isn't some kind of magic black box technology. It's the direct result of carefully building this automated create, update, and delete foundation correctly. If you don't implement that full C.U.D system, you're basically building a knowledge base that's just guaranteed to expire and become unreliable.
We covered that 3-stage architectural framework: raw material, processing, final product. We talked about the 4 essential components for any pipeline: triggers, inputs, processing, storage. And we really dug into why metadata is the absolute key to managing the RAG system lifecycle, especially for enabling those tricky update and delete workflows.
Right, so now that you understand how to build this synchronization system, This management system, the next level up, the next challenge, is really making that system smarter.
Think about this for a moment. We focus today mostly on simple operational metadata, right? Things like file name and date. But what if you started adding more semantic or usage-based metadata? What if you added fields like relevance scores, maybe derived from internal user feedback or logs, or perhaps tracking access frequency?
Ooh, interesting.
That could potentially allow your retrieval system not just to find information, but to actually prioritize knowledge that's highly used or recently relevant or highly rated.
Yeah.
You could move from just reliable data management towards, well, truly strategic knowledge retrieval.
Now that's the challenge for your next deep dive.
Thanks for diving deep with us today.
See you next time.